So with the new demonstration, right? My objective is to construct a structure for computing the e raised to the power x using Taylor series expansion, right? So I name the function as test exp function, right? And program test exp function. Let's emphasize the strong typing, Fortran 90 style, implicit null. Save the program in bin directory so that you have the facility of text coloring. So in Fortran format, test exp function for. So let's quickly write here the real x, and I write here PEXP, right? Calculation of EXP, right? Calculation EXP, and I require certain some more real term, numerator and denominator, right? And I require certain integers. So integers I, j, n, right? Okay. So here I start the calculation. Calculation exp. So I write here it is equal to 1 plus x, right? So I'm going to start it with the after the second term, right? So term equal to 0, denominator equal to 0, and numerator equal to 0, right? Okay. So I write here a structure. Do I varies from 2 to 7, right? I will compute the sum up to Taylor series expansion sum up to 7 terms, right? Okay. To provide here do 20 a label for do statement, right? So in this case, I define here the numerator. Numerator is equal to numerator. Right? Name must be consistent. Numerator is equal to x raised to the power I. Is this correct? Right. Power I. Right. Now, with respect to denominator, it is a factorial thing, right? So for factorial thing, let me calculate in this fashion. Denominator, right? Denominator equal to 1, right? And I write here another do structure. Do 10. J varies from 1 to I value, right? 1 to I value, and then calculate denominator equal to previous value of denominator asterisk j value, right? This is just like this structure is the program that you require in writing the factorial function, right? So here this should be completed. So and continue, right? And here, after having these two, so in the outer loop, I require the calculation of term equal to numerator divided by denominator, right? And then I have to update the sum. define some calculation of exp equal to calculation exp plus term, right? So update the term, and then here I 20. This is the end of the queue, right? So here let's get the answer. Print asterisk, print asterisk, calculation exp is equal to calculation e of x is equal to calculation exp, calculation exp. Okay, that's fine. And just to compare it with the exp function for x is equal to exp of x. That is the program part. I think I have not defined some value of x, right? So let's read it from the user. Let's read it from a user. Well, that must be before the calculation begins, right? So read asterisk value of x. So before that, what we are doing right here, print enter a value for x, right? So this is the calculation for that, right? So let's test this one and check. If I equal to 2, then a numerator would be x raised to the power 2. Okay, that's correct. Then denominator will set to equal to 1. Then do j equal to 1 to I. So 1 to 2, denominator 1 multiplied by 1, 1 multiplied by 2. So that will be 2 factorial. And then term will be updated and calculation will be updated, and that's it. So let's quickly test it. E77, my program name was test exp. Am I correct? Yes, test exp dot for minus o test exp dot exe. Oh, there are no compilation errors. Test exp dot exe. Enter a value for x. E raised to the power 0 is equal to 1, right? Now let's convert that thing into a function part, function form. So all the calculation instead of the reading of a value x, right? So let's copy this part. Let's group it and write it in function form. Right here, function calculation exp of x, right? And here real x and real calculation exp, and all the calculation part, right? And after that one, I would write the keyword return, right? And then end in the 7th column in function calculation exp, right? Just to make it separate from the main program. So all the calculation have been grouped in the function structure, right? So it's here, right? Now the way we call in the main program, let's change the variable xs Now this has become a function. We do not require definitions of these. They must be defined in function, right? Okay. So defined in the function. Now in the main program, I have only XS, right? An input variable. And now I define the variable for the function, right? That is to identify function in the main program called exp. So now the way we have called exp of x, right? I can call my function in the very similar way. Call exp for xs value, exp for xs value. Right. So the whole calculation is grouped in the function name called exp, right? So now let's compile the program again. Compilation is successful. I am delighted. I am excited. But you are not excited because you are expecting something else in my lecture. So enter a value for x. 0. Call exp xs1. From my function it is 1, and from exp function is 1. So today I have given you a proof that behind exp of x function at this Fortran, there is a Taylor series expansion calculation, right? So if you like, you can test it for other value, so 1.5, right? So there are slight differences. We have limited our calculation up to 7 terms. So if you improve the terms, there would be improvement in the answer. Thank you very much.